Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this 10th Standard Science and Technology part 1st. Friends, today we are going to discuss on question bank prepared by the SCRT. In this session, we are going to discuss on question number 2A, scientific reasons. The two chapters are covered over here today, gravitation and periodic classification of the elements. Let us start with that. Write scientific reasons, 2 marks each. Number 1, the value of acceleration g is greater at the pole than at the equator. The answer will be, the shape of the earth is not perfectly spherical, it is slightly flattened at the poles and bulged at the equator. As a result, the radius of the earth is at the poles is less than that of the equator. But acceleration due to gravity g, that is small g, on the earth's surface is given as g is equal to capital G m upon r square. Therefore, the acceleration due to gravity increases with the decrease in the radius of earth and vice versa. Hence, the value of acceleration due to gravity g is greater at the pole than at the equator. The value of gravitational acceleration small g decreases as you go above the earth surface. Friends, as the height of an object from the surface of the earth increases, the distance between the object and the center of the earth, that is radius, increases. But acceleration due to gravity g at distance r from the center of the earth is given by g is equal to gm upon r square. Therefore, acceleration due to gravity g decreases with the increase in r. As a result, the value of gravitational acceleration, that is g, decreases as we go above the earth's surface. The value of gravitational acceleration g decreases as you go deep inside the earth. Friends, the acceleration due to gravity g on the earth's surface is given as g is equal to gm upon r square. The value of g depends on the mass of the earth and the radius capital R of the earth. As you go inside the earth, our distance from the center of the earth decreases and no longer remains equal to the radius of the earth. Along with the distance, the part of the earth which contributes towards the gravitational force felt also decreases, decreasing the value of m. So due to combined result of a change in capital R and that of capital M, the value of g decreases as we go deep inside the earth. When we drop a feather and a stone at the same time from a height, the stone reaches the earth faster than the feather. Here, when we drop a feather and a heavy stone at the same time from the height, the feather experiences a buoyant force and a frictional force due to the air and therefore floats and reaches the ground slowly. But the buoyant force and the frictional force on the stone are much less than the weight of the stone and does not affect the speed of the stone much. Hence, when we drop a feather and a stone at the same time from a height, the stone reaches the earth faster than the feather. The weight of an object varies on different planets. The weight of an object of mass m on the planet is given by Wp is equal to mgp, where gp is the acceleration due to gravity at the planet. Also, acceleration due to gravity on the planet is given by gp is equal to gmp upon rp bracket raised to square, where mp is your mass of the planet and rp is the radius of the planet. Since mp and rp are different on different planets, the weight of an object will be different on different planets even though the mass remains constant. The value of gravitational acceleration g is taken to be minus g when studying the motion of an object thrown upward in a straight line. For motion of an object thrown upward, magnitude of g is same throughout the motion, but the velocity of the object decreases with the increase in height. For object thrown upward, the direction of acceleration due to gravity is opposite to the velocity of the object. Hence, the value of gravitational acceleration g is taken to be minus g when studying the motion of an object thrown upward in a straight line. The value of g at the center of the earth is 0. The acceleration due to gravity g on the earth's surface is given by g is equal to gm upon r square. The value of g depends on the mass m of the earth and the radius r of the earth. As you go inside the earth, our distance from the center of each decreases and no longer remains equal to the radius of the earth. Along with the distance, the part of the earth which contributes towards the gravitational force felt also decreases, decreasing the value of m. Due to the combined result, the change in r and m, the value of g becomes 0 at the center of the earth. Mendeleev kept vacant places in the periodic table. In Mendeleev's periodic table, the elements are arranged in the increasing order of their atomic masses such that chemically similar elements are placed together in a group. However, while arranging the elements, Mendeleev kept vacant places in the periodic table for elements not discovered till then. 3 of these unknown elements were given the names Eka boron, Eka aluminum and Eka silicon from the known neighbors. The atomic masses of these elements were indicated as 44, 68 and 72 respectively. He also predicted their properties. There was ambiguity about the correct position of hydrogen in Mendeleev's periodic table. Hydrogen resembles like alkali metals. It has 1 electron in its outermost shell like alkali metals. Its valence is 1 like alkali metals. It forms oxides, that is H2O, similar to alkali metals Na2O. However, hydrogen also resembles halogens. It is diatomic molecule H2 like halogen F2Cl2. It is 1 electron deficient to achieve stable electronic configuration similar to halogens. Due to this unique behavior of this hydrogen, it could not be as decided whether the correct position of hydrogen is in the group of alkali metal or in the group of halogens. Thus, there is an ambiguity about the correct position of the hydrogen in Mendeleev's periodic table. Boron and oxygen elements are placed in the second period in periodic table. Electronic configuration of boron is 2,3 and electronic configuration of oxygen is 2,6. Both boron and oxygen have electrons in the two cells K and L. The elements with the same number of cells occupied by electrons belong to the same period. Hence, boron and oxygen elements are placed in the second period in the periodic table. In the same periods, boron and oxygen elements have different atomic size. Friends, boron and oxygen are placed in the same period, however, their atomic numbers are different. Atomic number of boron is 5 and that of the oxygen is 8. In a period, as the atomic number increases from boron to oxygen, the positive charge on the nucleus increases. At the same time, electrons get added in the same outermost shell. This increases effective nuclear charge. As a result, electrons are attracted closer to the nucleus, decreasing the size of the oxygen atom. Hence, in same period, boron and oxygen elements have different atomic size. Lithium and sodium are included in the same group in periodic table. Electronic configuration of lithium is 2,1. Electronic configuration of sodium is 2,8,1. Both lithium and sodium have single electron in their outermost shell. Their valence is 1. In the periodic table, elements belonging to the same group have the same valency. Hence, lithium and sodium are included in the same group in periodic table. There was no definitive place for isotope in Mendeleev's periodic table. Friends, isotopes were discovered long time after Mendeleev developed the periodic table. Isotopes have same chemical properties but different atomic masses. Therefore, there was no definite place for isotopes in the Mendeleev's periodic table. The metallic character of elements increases while going down the group. While going down a group, a new cell gets added, resulting in an increase in the distance between the nucleus and the valence electrons. This results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electrons. As a result of this, the tendency of the atoms to form cation by losing electrons increases. The metallic character of an atom is its tendency to lose electrons. Hence, the metallic character of elements increases while going down the groups. The non-metallic character increases while going from left to right in a period. While going from left to right in a period, electrons are added to the same outermost cell. At the same time, protons get added in the nucleus, increasing the nuclear charge. Hence, these electrons experience greater pull from the nucleus due to increased effective nuclear charge. As a result, the ability of an atom to become anion by accepting outside electron increases. The non-metallic character of an atom is its tendency to gain electrons. Hence, non-metallic character increases while going from left to right to the period. In a group, the size of the atom increases as it goes down from the top. While going down from the top to bottom in a group, a number of cells increases. The outermost electrons go farther and farther from the nucleus, extending the radius and ultimately increasing the size of the atom even though the nuclear charge increases. Hence, in a group, the size of the atom increases as it goes down from the top. In group 2, beryllium and calcium elements, calcium is most electropositive element than beryllium. Electron configuration of this beryllium is 2,2. Electronic configuration of calcium is 2,8,8,2. Among beryllium and calcium elements, calcium has the least effective nuclear charge, exerting attractive force on valence electrons. This is because of the electrons in the inner cell, which lie in between the valence cell and the nucleus. These electrons act as a shield, reducing the attractive force of the nucleus on the valence electrons. Therefore, calcium can lose its valence electrons more readily than beryllium. Hence, in group 2, calcium is more electropositive element than beryllium. Elements belonging to the same group have the same valency. The valency of an element is determined by the number of valence electrons in the outermost cell of an atom of an element. All the elements in a group have the same number of valence electrons. Therefore, elements in the same group should have the same valency. For example, the elements of group 1 contain only one valence electron. So, the valency of elements of group 1 is 1. Similarly, for group 2, the valency is 2. So, friends, I think you understood all the scientific reasons from chapter number 1 and 2. In the next video, we will continue with the next type of the questions, that is scientific reasons from the remaining topics. Thank you for watching this video. We will meet in the next video. Till that, bye.